Hey, this is Mr. Ward, and I'm going to do a quick video key for Do Now 17.1. And so first thing you need to do is read this for 1 and 2. There is a new postulate in town. It's called the It's called the Hypotenuse Leg Postulate. Just like side, 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 and angle, side, angle, and side, angle, side. Hypotenuse proof congruency. If you have two right triangles, you can prove congruency if you have a congruent hypotenuse and leg of the triangle. Now, the hypotenuse is, of course, here's a right triangle. Okay, that is the most amazing right triangle you've ever seen. So there is a right angle, and this right here is the hypotenuse. It's the long part of it. And these two are the legs. Okay, so if you have a leg and the hypotenuse, okay, of two right triangles being congruent, then those triangles are congruent. Now, it says it really fancy here, of course. So the hypotenuse is the long part of the triangle, and it is opposite the right angle of the triangle. Okay, neat. So a little hint here, altitude, reminder, hint, altitudes are perpendicular to the base of a triangle, and all radii of a circle are congruent. That's theorem 18. A circle happens to be named for its center. Thus, the center of this circle is point O. Okay, so that gives us some information. So OF, given OF is an altitude, and given circle O. Our conclusion is we want to figure out, is EF congruent to FG? So is EF congruent to FG here? Okay, to prove that, it would be useful to prove that this triangle is congruent to this triangle. So let's see if we can do that. So let's start off by dealing with the givens. Okay, there's the givens. So OF is an altitude, and that is circle O. So since it's circle O, we can say that OG, not oof, is congruent to OE because they are radii of circle O. Okay, and since all, so we go theorem 18, and all radii of a circle are congruent. So let's mark that up. Okay, so that is congruent to that. Cool. Now we can add that. Angle OFE is congruent to, well, actually, first we say angle OFE is right, and also OFG is right. And we know that, actually, we probably should say OF is perpendicular to EG. Okay, so let's say, scroll down a little bit. So we can say that OF is perp to EG. Okay, and then we can say angle OFE and angle OFG are right. Okay, so let's mark that up. Okay, we'll use blue. So that's a right angle, and that's a right angle. Okay, and then we can say that and are therefore congruent to each other. We have the same measure. All right angles are congruent. And then we can also say that this leg here is congruent to itself. Okay, so we've established, actually we don't really need to say they're congruent to each other. We really just need to say, and therefore, triangle OEF, and triangle OGF if I can type an O here, OGF are right triangles. Okay, by definition of a right triangle. Okay, so now we're actually on the right track. So I was getting distracted by trying to prove angles being congruent and stuff. I don't need to do any of that stuff since I have now access to the hypotenuse leg. All I really need to do is prove these are right triangles and find a leg and a hypotenuse. I've already got hypotenuses that are congruent. I just need to find a leg that's congruent. Now there's a leg that's pretty obvious. OF is itself bireflexive. Okay, so now we can say triangle OEF is congruent to triangle OGF. That's an OGF by hypotenuse leg. And then we can say EF is congruent to GF, which is my preferred way of saying it, by kappa kataca. Okay, since the two triangles are congruent, corresponding parts of congruent triangles are congruent. Well, let's take a look. Let's tidy up this a little bit. Okay, let's take a look at number 2. Number 2, we are going to probably need the reflexive property in the hypotenuse leg postulate. So we have some information. We're given BC is perpendicular to AC. So let's do that. BC is perpendicular to AC. And that'll be important later because these are going to prove that these are right triangles. BD is congruent to AD. I'm sorry, perpendicular. This means perpendicular. So BC is perpendicular to AC and BD is perpendicular to AD. Now, we also know that AC is congruent to AD. So we can mark that up to AC is congruent to AD. All right, so let's do the givens. So the givens. Okay, and then we can say triangle ABC and triangle ABD are right triangles by definition of a right triangle. They both have a right angle in them. Now we can say that AB is congruent to AB by reflexive property. Okay, so we'll mark that up. Grab green for that. So this is congruent to itself. And now we have a hypotenuse and a leg, hypotenuse and a leg. So we can now prove, now we're trying to prove AB bisects CAD. Well, to do that, it'll help to prove that these angles are congruent. So we can now prove that these two triangles are congruent. Okay. I should have mentioned that earlier on. I apologize. That is our goal. So I made an assumption. We're just trying to prove these triangles are congruent. So they are congruent. So triangle ABC and ABD are congruent. Make that this. Oops, actually, not that, but that. Okay, by hypotenuse leg. And then we can finally say that, well, not finally, we can say angle CAB is congruent to angle PAB, okay, by kappa kataca. And then we can say AB bisects angle CAD by definition of an angle bisector. And the reason it does that is if those two angles are congruent, this angle here is congruent with this angle here, then AB bisects CAD. Okay, then the last one on the do now, proving that RM, okay, RM here is congruent to WT. Okay, so we know that KPR as a triangle is congruent to SAW as a triangle. Okay, that's something we've been given. We know that RM bisects, let's see, RM bisects KRP. We know that WT bisects SWA. So, okay, let's deal with the givens. Now, to prove that RM and WT are congruent, it would be useful to prove that this triangle and this triangle are congruent, or this triangle and this triangle are congruent. I think we can do that because after the givens, we can start to say that some pairs of sides and angles are congruent. So SW is congruent to KR by kappa kappa ka. Corresponding parts of congruent triangles are congruent. We can say that angle S is congruent to angle K by kappa kappa ka. Okay, and let's see. We can also say that we can prove that angle SWT and TWA are congruent by definition of angle bisector. But let's start labeling some things we know. Okay, so we know that this is congruent to this. We also know that this angle is congruent to this angle. Okay, now it would help to be able to prove that this angle is congruent to this angle, because then we can say angle side angle, and then by kappa kappa ka we'll prove that. Well, we know the two triangles are congruent, so let's state this. This angle is congruent to this angle. We know that. Okay, so now we can say angle SWA is congruent to angle KRP by kappa kappa ka again. And then we can say angle SWT, a little bit, SWT is congruent to angle KRM by division, because we've bisected these angles, so we've divided them into two equal parts. So if these are congruent, half of congruent angles are congruent halves as well. So now we can prove, label that, we'll go with blue this time. We can say that this angle is congruent to this angle. Oops, undo that. There. So those two angles are congruent. It's also true that this side is congruent to this side, but that's not helpful to the current path of our proof. We could have taken that side and proven these small triangles are congruent, and it'll do the same job. Okay, so you could have taken that route. And now we can say that RM is congruent to WT by, I'm sorry, actually I've got to do one more thing. We're going to say that, rename these triangles. Since we've labeled them as angles, now we can call them triangles. The triangle has three vertices that happen to be of those angles. Okay, so we can do that now by angle side angle. Sorry, I'm a little all over the place here. And now, once we have all that, now we can say that RM is congruent to WT by kappa kappa ka. Okay, I hope that helped, and I apologize for being a little rambly all over the place here. But it exposed my thought process as I'm working